All right, so it takes 8 seconds for you to breathe in and out. That's what we're going with, 8 seconds, which is probably like about average, okay? So 8 represents what? What word did we use for one full cycle of the function? The period of the function. One period of the function. I know I'm asking you to remember stuff from a few units ago. One period of the function is 8 seconds. When your lungs are full, they hold 4 liters. When they're empty, we're going to say it's 0. Like, I'm not a doctor, but I would imagine it probably never gets to like actual 0. But like for the purposes of this, we're going to say it's 0. So like the peak is going to be 4 liters. Then the valley is going to be 0. Where is the center then? Where can I kind of dot in the center line? At 2. So 2 is going to be where our center is. And let me go ahead and fill in the table. We're going to kind of do the graph and the table together. So we're going to start with 0 seconds. We said the period was 8 seconds. So it's going to be 0 to 8. And then how will we break that down in between in the seconds? Yeah, good. 2, 4, 6, 8. 4 would be halfway in between. So 2, 4, 6, 8. And we're going to start on this center line. Breathe in, it's going to go up, come back to the center. Breathe out, it's going to go down and then come back to the center. So we're going to start at 2. And then what's the next number going to be? Good. 4, it's going to go up to 4 and then back to 2. And then where? 0, even though it's probably not actually like technically 0. I don't think you can have nothing in your lungs if you're alive, but like we're going to just say it's 0 and then back to the center at 2. So what I want you to do is graph that. That's one period of the function, and then graph a second period of the function. I just want you to keep it going a little bit further, and then you can kind of compare with the person next to you. I'm going to draw it too. It might not look super perfect. That's okay. I'm not like grading your art skills, but it should look like a wave. So we got something that looks like this. Good. Breathing in, breathing out. Okay. What we want to do is write an equation for that. So out front is the amplitude. Okay. What is going to be our amplitude? How far from that center line do we get? 2. So 2 goes out front. I'm going to come back to this because that's going to be the tougher part. And then this is your vertical translation. That's how far up or down you move that center line. We dotted it in. So what goes there? 2. Yeah, that's also 2. Now, do you remember how to get the period of the function? 2 pi over, and this would be b. Remember, that's that b value. So 2 pi over b, that's what we're trying to find. That's that blank, is how much? What is the period of this function? 8 seconds. We want that to equal 8, and then we're going to have to do some algebra to solve that. So what would you do to start solving? Your goal is to find b. Yeah, multiply b over, because then you won't have the fraction anymore. 2 pi equals 8b. And then what? Divide by 8. And then we'll just reduce the fraction. So when you divide by 8, 2 pi over 8, that would reduce to what? Good. So pi over 4 is what goes right here. So that's our equation. And then I'm going to ask you some questions, and you can get it just from looking at the graph that we did. When, so this should be in seconds, when do your lungs hold 0 liters of air? So look at your graph. At what time do we have 0 liters in our lungs? 6 seconds, and then when else? 14. Now I know it's going to go off the paper, but when would the next one be? 22, good. And then like, etc. What are you adding to get the next one? Yeah, 1 period of the function, good. So you're adding 8 seconds each time to get to the next one. When, so seconds, when do your lungs hold 2 liters of air? So that's kind of where we have this dotted line in here. So when do we have 2 liters of air in our lungs? Where's the first one? Good, 0, and then the next one, good, 4, 8, 12, 16 seconds, so on and so forth. Now, what are you adding for that one? Because it's not 8 this time. 4, why is that? Why isn't it a whole period? Yeah, it's the midline, so you're hitting that more often. Do you see that there? But it's spaced like nice and even. You're adding 4 each time. And then when do your lungs hold 4 liters of air? Okay, well, when's the first time we have 4 liters? Right, 2 seconds. And then the next time is 10 seconds. And I know it goes off the paper, but when would be the next time? 18 seconds, etc. And you would add 8 each time. This is review. This was a warm-up. We have done this before. Do you remember when I did real world problems? We did the one with the Ferris wheel goes up and comes back down, all of that. Here's where I'm headed with this, and what you're going to learn today is be able to answer this question. Because remember, I only asked you like the nice, neat ones. Okay, now we're going to do like the messy one. When, so in seconds, do your lungs hold 1 liter of air? So look back at your picture. Here's 1 liter. So what times do our lungs hold 1 liter of air? Well, it would be right here and right here. But when is that? Like somewhere between 4 and 5. And then what would the other one be? Like, my picture's not real perfect here. Like somewhere between 7 and 8. And then also these times over here, like it's gonna be cyclic again, but it's not like nice and even, okay? But that's what we're gonna do today, is I'm gonna teach you how to find those. So what I want you to do is set this aside. I'm gonna teach you the lesson, and then we'll circle back to this and you'll be able to answer that question. Does this make sense? So this says, solve over 0 to 2 pi. So that is just once around the unit circle. And you're gonna need some of the stuff that I wrote up here. I wrote the Pythagorean identities, and I wrote that double angle identity. Sine 2x equals 2 times sine times cosine. Also, you're gonna need this as well. Do you remember this, all students take calculus? Let's review that real quick. What functions are positive in the first quadrant? All of them, that's what the A stands for, all. What's positive in the second quadrant? Sine, and so also cosecant, the reciprocals go together. Positive in the third quadrant would be tangent and cotangent. Positive in the fourth quadrant was the C, cosine, and then also secant. Okay. Solving equations is familiar territory though. You've solved equations before. These ones just have trig in them. What would you start doing to get x by itself? Just fall back on your instincts. Subtract 1, good. You guys do know what you're doing. It's not any different. Solving an equation is familiar territory. It's get x alone. All right, then what? Divide by 2. So sine of x equals -1/2. You're going to get something that's on the unit circle. You're going to get a 1/2 or a square root of 2 over 2 or a square root of 3 over 2. Otherwise, like not a doable problem, or you would need a calculator, which I'm not going to give you. Okay, so you're going to get something that's on the unit circle. Now here's where we draw the picture. Remember, the picture is your work. Okay, you have to figure out what quadrants you're in. This is sine and it's negative. So look at that, or just think about it. Sine's the y value. Where would the y value be negative? Because there's 2 quadrants where this is going to happen. 3 or 4. So we're going to draw triangles in quadrants 3 and 4. They're the exact same triangle, just reflected. So I'm fine if you just label one of them, one or the other, because they're the same triangle. Sine is the y value, so that's where that goes. What is the angle across from a half? That is pi over 6. And again, you can label both of them if you want to, but one is good enough for me. So we are going to get two answers. It's the amount of rotation. And for these, we're always going to rotate forwards. So if we rotate forwards, how far did we go to get right here? Oh, what is that? 7 pi over 6, because the 1 whole pi would be 6, 6. You went a little bit further, that's 7 pi over 6. This is like keep calm and know the unit circle. That's why I made you fill out so many units. And if you rotate all the way around to this one, how far did you go? 11 pi over 6. So those are your two answers. Let's try it again. What would you do for this one to start trying to get the x by itself? Yeah. Subtract 5. You get 2 cosine x equals -1. Divide by 2, and you get -1/2. So kind of the same as the first one, but it's going to be different because this one's cosine. We need quadrants where cosine is negative. Cosine is the x value. So you can look at that or just think about cosine being the x value. Where is the x value negative? Good, nice. And again, they're the same triangle, just reflected. So you can just label one of them. Cosine's the x value, so that's where the -1/2 goes. I know that's really small, I'm sorry, I'll zoom in. That means the other side is square root is 3 over 2. So what's the angle across from that? Pi over 3, perfect. And so we get two answers. And remember, it's how far you rotated. So how far did you rotate to get here into quadrant 2? That's 2 pi over 3. And then the one in quadrant 3, good, nice. If you know the unit circle, which I know that you all do, you will be just fine. Is this making sense or question, or are we like, we're hanging in there? Okay. We'll finish this page and I'll give you guys a brain break. All right, number 3, trying to get x by itself, you would add 1. And then divide by 2. But this one has a squared. So how do we undo a squared? Square root. When you put a square root, what do you have to put in front? Plus and minus. Okay, so it's going to be sine of x equals plus and minus square root of 1/2. Okay, square root of 1 is 1. Square root of 2, square root of 2. Without a calculator, I don't know exactly what that is. And then that would equal plus and minus what? Oh my gosh, guys, it came out to something on a unit circle. It's going to. If you don't get something on the unit circle, you have done goofed, okay? Because it has to. Now, I love when there's a plus minus because the what quadrant are we in question goes away. If it's both plus and minus, what quadrants are you in? All of them. So it's nice because you don't have to worry about it. And also it looks like a bow tie, which I just like. I don't like having to worry about it. If it's plus minus, it's all of them. So we have the square root of 2 over 2 triangle. And so what does that mean the angle is? Pi over 4, perfect. And we're going to get 4 answers. And they are pi over 4. And then what's the next one? Just keep going. 3 pi over 4, perfect. 5 pi over 4. 7 pi over 4. You guys rock. This one, we're going to need one of the identities I wrote on the board. Do you see how it's sine of 2x? And I don't make you memorize this one. Sine of 2x, you can replace that with 2 sine of x cosine of x. Okay, so we're going to replace this with 2 sine of x cosine of x. We're getting into like some more complicated ones here. Now we're going to factor that. Look at both of these terms. What have they both got? They both have a sine of x. So that's our greatest common factor. We're going to factor that out. What's left after you factor that out? 2 cosine x, good. minus, oh good, 1 equals 0. And then we're going to set each of the factors equal to 0. It is just like this. Watch, let me give you like an algebra 2 example. Give me a number. So like say you had this, what would you factor out? X, you'd be left with, and then you would get x equals 0 and x equals 7. It's the exact same thing. It just has sign in it. Are you following? We factored out an x. This one we factored out a sign of x, right? So we're going to set each of these factors equal to 0. So we get sine of x equals 0. And we get 2 cosine x minus 1 equals 0. So it now became a part A and a part B problem. So you have to solve both of them. Now sine of x equals 0. That's not going to be a triangle. That's going to be our circle. Sine is the y value. So using words like up, down, left, right, where is the y value going to be 0? There's 2 places. Right and left. Okay, so right here and right here. So if you start here, you've rotated precisely nowhere. So what is that answer going to be? Yeah, nothing pi. And then what's the one on the other side? Yeah, 1 pi. And then we're going to need to solve this one. So you would add the 1 and then divide by 2. So you'd have cosine x equals a half. And then you have to figure out what quadrants you're in. Again, like, because I sometimes get people like, well, I can do it without drawing the picture. Yeah, but remember the picture is your work. Okay, so you have to show me that. Cosine's the x value. So what quadrants is that going to be positive in? 1, good. And which one other did you say? 4, good. Cosine's the x value. That's where the half goes. That means the other side is the square root of 3/2. And so what's your angle? Because that's what we're getting at, is what's the angle? Pi/3, perfect. And so we get 2 answers from that one as well. It would be pi/3. And then what's the one in the 4th quadrant if you rotate all the way around? Good, you guys know the unit circle, awesome. If you're like, hey, I need to fill out another one, I've still got extras back there. You're welcome to take as many as you need. All right, let's try a couple more and I'll give you a break. I know this one looks super complicated. Looks like fun, guys. All right, these are the 2, I know you're all ready. These are the 2 terms. What do they have in common? What have they both got? Cosine squared, good. So we're gonna take cosine squared out. We're factoring that out. It's greatest common factor. And so you're left with square root of 3 cotangent x minus 1, good, equals 0. And so again, we're going to set both of those equal to 0. It looks scary because of the cosine squared and the cotangent and the square root of 3 and all that, but like mathematically, remember this is all that you're really doing. So here you would square root, but we kind of don't need a plus minus because what's your square root of 0? 0. And again, that's gonna not create a triangle, it'll be a circle. Cosine is the x value. So where is the x value 0? Using words like up, down, left, right. Up and down. And so those 2 answers would be what? Pi/2 is the first one, good. 3 pi/2, awesome. And then this one, what would you do to start solving that? Add 1, good, and then divide by square root of 3. So it's going to be cotangent equals 1 over square root of 3. Now you kind of have to take that backwards a little bit further, which is tough. It's going to be the 1/2 over square root of 3/2. Because what would happen when you simplify this? 2's would cancel and this is what you would get. If you feel stuck on that, because I know that that's hard, it's either going to be 1/2 over square root of 3 over 2 or square root of 3 over 2 over a half. Like those are the only two options. All right, where is cotangent positive? 1 and 3, good. So this looks kind of weird because your triangles are sort of like across from each other. And cotangent is x over y. So 1/2 goes here, square root of 3 over 2 goes here. Again, you can label the other one if you want, but I'm fine if you just do 1 because they're the same triangle. Angle is pi over 3. And so your answers are pi over 3, and then what's the other one? 4 pi over 3. Perfect. All right, let's try one more. We are again going to need one of our identities for this. See that secant squared there? Secant squared can be replaced with what? Tangent squared plus 1. So we're going to replace this with tangent squared plus 1. And you're probably like, how on earth did that make it better? I'm going to rearrange it, and then I hope you'll be able to see it. I'm not going to change anything in this step. I'm just going to write the terms in a different order. So you have the tangent squared, and then 2 tangent of x, and then plus 1. Does that remind you of like this? And then what was it, plus 1? It's the exact same thing except with a tangent in it. Here, let's do this one real quick. When you go to factor that, how does x squared split? This is like welcome back to algebra 2. Yeah, that'll be x and x, and then 1 would split what? 1 and 1, and then what symbols would you need? Good, because 1 plus 1 is 2. This is going to be the exact same thing except with a tangent in it. Tangent squared is going to split tangent and tangent. And 1 is going to split 1 and 1, and they would both be positive. It is algebraically the exact same thing. It just says tangent. And what's kind of nice about that? Like, what would you maybe be happy about with that? Like, what's good about that? They're the same thing. So like up here, when we factored, you ended up with 2 problems to solve. Here, you're only going to have 1, so it's not as much work. You too. So we're going to subtract over the 1. You'll have tangent equals -1. And tangent's a little bit tricky because the -1, does that make you think of the circle? But it's not. What quadrant is tangent negative in? 2 and 4. Yeah, tangent and cotangent go like across from each other. What do the sides have to be so you can end up with -1? Good, it's square root of 2 over 2. It's just the other one's negative. That's how you get the -1. And so your angle is pi over 4. And so what are your 2 answers? 3 pi over 4, that's the one in the second quadrant. Good. Oh my gosh, you guys know the unit, sir. I'm so proud of you. Rock. If you know that circle, do you understand now why I made you fill it out so many times? So when we get here, you know, just know them. All right, do like a 5-minute break and then we'll do the other side of this. All right, so the only difference with these ones on the back is over here it said solve for once around the unit circle. Over here it says solve for all solutions. So to relate that to the breathing, like you're gonna keep on breathing, like this is gonna keep on going forever. We're gonna say like all the answers, okay, forever and ever and ever, infinitely, okay? So you're either going to add 2 pi n, that would be like once around. You would add pi n, that's if you hit your answer every halfway around, or pi over 2n, that's if you hit another answer every quarter of the way around. So you're just going to add one of those to your answer. That's the only difference. All right, everything else we did is the exact same. So how would you start solving this one? Oh my gosh, and it comes out to square root of 3 over 2. I know, right? It's like it has to be on the unit circle or something. So sine is the y value. What quadrants would the y value be negative in? 3 and 4, good. So that y value is that negative square root of 3 over 2. That means the angle is what? Pi over 3, good. I'm not going to yank you in the hall and make you have a verbal exam. I just like when you guys talk to me, because otherwise it's just me talking to myself and that's boring. All right, so here's how we're going to write our answers. This first one would be 4 pi over 3. And you're going to have to add 2 pi n. So you're going to hit that answer every once around. Do you see what I'm saying? Like you have to go the whole way around to get there again. And then you're going to have x equals, what is this one? Five pi over 3. And again, plus 2 pi n. You would have to go the whole way around to hit that answer again. It is literally what we just did on the other side of the paper, but plus a 2 pi n. That's it. So let's try it again. For this one, you would subtract 1. So you'll have cosine squared equals -1. And then to get rid of the squared, you would need to square root. But what's going to happen there? Can you square root a negative? Well, you can actually. Square root of -1 is, do you remember? It's imaginary, but we don't do imaginary answers with these, so it would just be no solution. So that was easy. Didn't get an answer. So actually, I made this the exact same problem, but it's going to work out this time. You would add the 1. And now you can square root. But when you square root, you also have to put plus and minus. So square root of 1 is 1, but it's plus and minus. I like when the plus and minus happens. I don't know. I feel like that takes away part of the question, like where's it positive, where's it negative? Well, you don't have to worry about it because it's all the time, right? Yeah, or well, see, this one's not going to be a bow tie though, unfortunately, because it's 1. So it's going to be a circle. I know, I like the bow tie too then. So cosine is the x value. We need places on the unit circle where the x value is either +1 or -1. So where does that happen? Yeah, right and left. I'd like you to, if you like put a point there and there, I'll accept that. I want to know you understand where it is. So I label them, but I guess if you didn't put that, I'd be okay with that. Because you're going to write this in your answer. So it would be x equals. Now, if you're there, you have rotated nowhere. So that would be nothing pi. And you only need to go halfway around the circle to hit your next answer. Look, you go halfway around, and then if you go halfway around, you hit another answer, and then halfway around, you hit another answer. It is exactly like the breathing one that we did, where you hit that answer every half of the period. Do you see what I'm saying? So you only need to add pi n, not 2 pi n, and that takes care of it. You just keep going around and around the circle forever and ever. All right, so for this one, you would subtract 1. And then divide by square root of 3. Now, this is tricky because you have to take that backwards. It's going to be -1/2 over square root of 3 over 2. The 2's would cancel and you would get 1 over square root of 3. We're just like doing that backwards. So tangent is negative in quadrant 2 and quadrant 4. And tangent is y over x, or opposite over adjacent, however you want to think of that. So it's going to get labeled with the 1/2 is the opposite, negative square root of 3 over 2 is the adjacent. And so what's the angle? That's the big deal here, is what is the angle? 5/6, perfect. So your answer is going to be, how far do you rotate to get here? 5 pi over 6, perfect. And you only need to go halfway around to hit the next answer. Look it, you would go halfway around and hit this answer, and then go halfway around again and hit this answer, and then go halfway around again. Like, you only need to go halfway, so it's plus pi n. You're probably like, what would it look like for pi over 2n? That situation is kind of rare. You would have to have this bow tie situation and have it be the pi over 4. Do you see what I'm saying? And then you could like just go a quarter of the way around to keep hitting another answer. But it would have to be the pi over 4 because that's the only one that's spaced evenly like that. So it doesn't happen that often. All right, what would you do to start solving this? Yep, add 3. And then square root. When you square root, you have to put plus and minus. Good. So this one will be the bow tie. Will be in all the quadrants. Now, again, this is tricky. You have to back that up a step. It's going to be square root of 3 over 2 over a half. Because if the 2's cancel, you'd have square root of 3 over 1, which just is square root of 3. But again, remember, if you, I don't want you to get hung up on that. It's either one way or the other. So if you get stuck, you got a 50-50 shot. Okay. So we are in every quadrant. And tangent is y over x, or opposite over adjacent, however your brain wants to do that. You can just label one triangle, it's fine. All 4 are the same. The goal is the angle. So what's the angle? Pi over 3, good. Now, I didn't get out a protractor and measure this exactly, so my picture's not perfect, but you get that these aren't evenly spaced, right? Again, to relate it back to the breathing one, do you see how these aren't evenly spaced from each other? Like you get 2 answers and then kind of a gap and then 2 answers. Like it's not perfect, all right? So we're gonna have x equals pi over 3, that's the first one, plus pi n. That will take care of these 2. Because you'd have the pi over 3, and then if you go halfway around, you're going to get this one. If you go halfway around, you're going to get this one. If you go halfway around, okay, so that takes care of these 2. How could we write it for the other 2? Good, that'll be perfect. This one is 2 pi over 3, and then plus pi n, because this would be 2 pi over 3. Halfway around would get you to the one that's in quadrant 4. Two pi n. Yeah, so the other way you could write this is pi over 3 plus 2 pi n, 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi. Like you would take each one individually and add a rotation. This way is shorter, but I would have to accept that answer because it's correct. Yeah, it's more writing though. All right, here I'm going to need to replace the cosecant. So I just recopied that whole thing. I left a blank where the cosecant is. What can we replace cosecant with? What is that? Or, oh, it's not squared. So this one's not up there. I'm sorry, I know I kind of tricked you because there's not a squared. 1 over sine, good. You're probably like, how did that make it better? That looks worse, Miss Cole. Well, I know. At least now it's all sine. So what we're gonna, yeah, that's true. Okay, thanks for coming with me on that. So what we're gonna do is we're gonna multiply each term by sine of x. Why, you ask? Well, what would that do? If you multiply through by sine of x, what will that accomplish for us in this term? Good, we won't have a fraction anymore. It'll cancel out, okay? So sine times sine is sine squared, minus 1 times sine would just be sine. And then here they cancel, which was like the whole point. And so it'll just be minus 2. 0 times anything is 0. We're getting there. That looks a little bit better. Does it remind you of a trinomial? Like it should. Okay, so how would we split this up? Sine x, sine x. It's exactly like when you split x squared into x times x. It is no different. 2 is going to split 2 times 1, 1 times 2, wherever you want to write those. To get a -1 sign in the middle, you would need -2 plus 1. And then it became a part A and a part B. You're just going to solve them separately. So this one, if you set that equal to 0, you would add over the 2, you would get sine of x equals 2. That's not going to work because sine is a wave that stays between what two numbers? -1 and +1. It's never going to equal 2. So this is not going to work, which is almost kind of like, yes, I don't want to do any more work. This one, if you set that equal to 0, you would subtract over the 1. And then you need a place on your unit circle where sine is -1. Sine is the y value, so that's going to be down here. And so what is that angle, like that amount of rotation? 3 pi over 2, and what do you have to add to get there again? Good, the whole way around, so 2 pi n. What I want to go back and revisit is the breathing problem. Humor me. I like this problem. It's good. It helps you understand what it is we're actually doing and how it like relates. When do your lungs hold 1 liter of air? What you would want to do is take this equation and set it equal to 1. Put the phone away, right? We're almost done. 2 sine pi over 4x plus 2. That was our equation. We're going to set it equal to 1 and solve it. Sorry, that equal sign is bad. I'm going to rewrite it. So what would you do to start solving that? Subtract 2. 1 minus 2 will give you -1. All right, then what? Divide by 2. Oh my gosh, guys, it came out to -1/2, and that's on the unit circle. Crazy. It's sine and it's negative. What quadrants is sine negative in? Good, because it's the y value, so 3 and 4. And the angle is pi over 6. Perfect. The only difference with this one is it's not x equals, it's pi over 4x equals, because there was a pi over 4 in. So pi over 4x equals, what is this first amount of rotation here? 7 pi over 6, good. And then the other one, pi over 4x equals 11 pi over 6. Now, what's really nice about all of these, I know, like there's nothing nice in the hate. What's going to cancel out on both sides? The pi's are all gone, which is nice. And then you would just multiply by 4. So 7/6 times, you know what, I want that as a decimal. Let me just type that in the calculator real quick so we can relate it back to the graph. That is 4.6 repeating seconds. And then here we'd have 11/6 times 4, which is 7.3 repeating seconds. Look back at the graph. 4.6, 7.3. Isn't that like about where we saw these? And then if you wanted these next two, you would just add what? What was the period? 8. So if you want the forever answer, you would have plus 8n to both of them. And that would give you the answers ongoing continually forever.